Marmot Dam has operated in the Northwest United States for nearly 100 years. Now, a team of experts is taking it out.
Shot ready to fire.
They've got just 4 months to break down 22,000 tons of concrete and steel and clear nearly 800,000 cubic meters of sand, gravel, and boulders, so endangered species of salmon can return to their spawning ground. Pulling this off will take a radical and unproven plan.
Oh, look at, they're underneath.
They'll use 21st century science and technology to harness the force of a perfect storm.
Whoa, it's starting to go.
Without losing any lives along the way.
Get back up, we're starting to lose the bank. Hurry up. Big dams are as commonplace as epic rivers in the northwestern United States. Here, among Oregon's Cascade Mountains, Marmot Dam has tapped the Sandy River's hydropower for almost 100 years. But the dam is old and tough on migrating fish. The power company, Portland General Electric, has decided to retire this expensive structure and replace it with other sources of energy, such as wind power. John Essler is a PGE manager overseeing this project. His job is about difficult choices.
Our customers expect us to do the right thing, and if a project cannot be run economically and protect the salmon, they expect us to remove the project.
But deconstructing a dam of this size and age is a major engineering challenge.
There's a lot of things that we don't know that we'll learn as we actually see it take place.
Nothing's happening.
This dam removal is a grand experiment.
Breaches we plan on using.
PGE has assembled a top-notch team to help them.
And we'll be watching the weather.
Engineers, explosive experts, scientists, and even weather forecasters. If their plans are successful, the Sandy will run free again. From its headwaters on the slopes of volcanic Mount Hood to its confluence with the Columbia River, 80 kilometers away. But it won't be easy. Marmot Dam looms 5 stories high and nearly 60 meters across. A canal sits on one side and an old fish ladder allowing salmon a way to cross on the other. The dam itself is constructed of 22,000 tons of concrete and 90,000 kilograms of reinforcing steel. To break it down, the deconstruction crew must first divert the river with a temporary dam to create a dry, safe work area. Next, they'll use explosives to crumble the old dam, then remove the concrete and steel for recycling. Finally, with Marmot gone, the team will take on their biggest challenge, removing the sediment that's built up behind the dam for almost 100 years. 16 million tons of boulders, gravel, and sand, forming a backward doorstop, stacked right up to the lip of the dam. Even with Marmot gone, this massive clog could continue to block the river. But removing this much debris with backhoes and dump trucks is not an option. Contractors have just 4 months to safely complete the project because another clock is ticking, a biological clock, for wild salmon returning to their river.
Salmon are a real symbol to people in the Northwest. It's a symbol of the recreation and the cultural resources we've had and want to continue to have, in spite of a strongly growing population.
The salmon are born in the Sandy River's fresh water, then travel downstream to the Pacific Ocean. Once they reach maturity, the fish travel thousands of kilometers back to the Sandy in a race to spawn before they die. Many have to climb the dam's outdated fish ladder to get to their native habitat. Over the decades, the fish population has dropped from as many as 20,000 to around 5,000. Some species, like the Chinook and coho, have even made it onto the endangered species list. To minimize the project's impacts on fish, removing the dam can only occur while the river is at its lowest and before the biggest runs return. Contractor Nat McDougall is in a tight spot.
We basically have to do this job in about half the time that normally would take under normal condition. It'll take 6 and 7 days a week and some long hours to get finished and meet the deadline.
With no minutes to waste, the project launches promptly on July 1st. Stage 1. Nat McDougall's crew starts building a gravel and clay structure upstream of Marmot. Known as a cofferdam, this will hold back the river during Marmot's deconstruction. They'll build the specially designed cofferdam on top of 5 stories of sediment. Inside it, drillers will thread wells and pumps down to the riverbed. The pumps will extract water from the sediment, making it part of the protective structure. The cofferdam will also include a steel bridge, so heavy equipment can cross the diversion canal. Once they complete the project, crews will stop the pumps, allowing water to resaturate the sediment. Then the gravel and clay dam will dissolve harmlessly into the water. But until then, it will have to hold.
We're working behind a temporary dam, and if any kind of failure were to occur, it would be a fairly major catastrophe.
The cofferdam is designed to hold back flows of 3 million liters a minute. That's enough in summer when the river is low. But this region gets over 94 centimeters of rain every year. And after the storm season starts in the fall, the river can crest at over 8 times that amount. Far more than the cofferdam can withstand. The team must complete the project before summer ends. In the meantime, keeping the river out of the work area is the contractor's top priority. Lives depend on it.
Trying to pump the water out and control that water, that is the biggest single risk we have. We run the risk of the river rising and coming into our work, and that would not be good.
Crews work around the clock to complete the cofferdam. Well drillers bore 18 meters through the sediment trapped behind Marmot. Then lower well casings into the holes. Inside these wells go the pumps that'll serve as their life support system. The pumps must operate 24 hours a day to keep the river from dissolving the temporary dam. With construction underway on the cofferdam, research hydrologist Gordon Grant tackles the project's biggest challenge, working out how to remove the silt and debris that's built up behind the old dam for nearly 100 years.
We pull the dam, there's going to be sand everywhere through here. It's going to end up in all these kinds of nooks and crannies.
His biggest concern is that the freed sediment could clog the river, blocking fish or burying their eggs.
There's never been a human-constructed dam coming off a river that has involved this much release of sediment. We've never seen what happens when 1 million cubic yards of sediment comes down a river all at once.
PGE has decided on a radical scheme to wash the debris away in one bold move. But it's a method that's never been attempted on this scale. So Gordon Grant is being sent on assignment to see if the plan will work. Portland General Electric has asked researchers at the University of Minnesota's Center for Earth Surface Dynamics to create a scale model of the dam deconstruction project. It's 13 meters long, with a replica Marmot Dam in the middle, and a mile of the Sandy River represented below and above it. Engineer Jeff Marr designed the model based on laser measurements taken from the field.
The red lines are cross-sections that we use to construct the model. They actually tell us what shape to form the concrete.
It even has scaled down sand and gravel sediment packed to the lip of the dam. They've built this model in order to test PGE's plan for flushing away the sediment in the real world. The concept is simple. Once contractors remove the old dam, they'll wait for a fall rainstorm to fill the river behind the cofferdam to its bursting point. Then, they'll release the water, directing the flow to wash away the mountain of sediment. But controlling a storm flood with manpower and machinery is an ambitious and potentially dangerous operation. Researchers hope their miniature Marmot Dam will help them learn how to manage this dynamic process. The model is ready for a test drive. First, they build the cofferdam, including a pump system. Next, they remove the old dam. Now, the researchers simulate a series of events that will happen in the field. Fall storms arrive.
Of course, we have the luxury of being able to turn the river off and on. Chaps have to do this in the field. They have to do it with a live river. I see water coming. It's starting to rain.
Pumps in their cofferdam are turned off and removed.
Okay.
Most importantly, a notch is cut to guide the water flow. In the field, this will have to be done by men and machinery. Then they block the canal, diverting the water around the site.
The diversion canal's blocked. Okay, here we go.
And the scale model river rises.
All right, so we're going up to 2,500. Oh, you're getting erosion here.
Within minutes, the water starts to cut through the notch and begins scouring away the sediment behind the cofferdam.
Oh, you look at, there, underneath. Yeah. There it goes, there it goes.
Nice.
Wow, look at that thing go! I would not want to be down in the hole with big slumps like that coming off. I'm not that brave.
The equivalent of 16 million tons of material moves safely downstream. In this room, at least, the plan is a success. The model proves the plan could work, but project coordinator Tim Keller isn't convinced. In the field, this notch will have to be cut by his team using large excavators, a potentially dangerous maneuver during a flood.
I will not allow the construction workers to be put at risk for breaching this cofferdam based on some modeling scenario.
But that day is still a long way off. First, they've got a dam to remove. The original dam was completed in February of 1913. It took 7 months to build under challenging conditions. Workers used whatever materials they had nearby, mostly rock and timber. Their achievement is legendary to PGE veterans like John Essler.
It's a legacy project to us. It was one of our first hydro projects. So much of this stuff was done by hand and horsepower. Very little mechanical stuff except some steam equipment.
Over the years, the dam has needed a few upgrades. Ironically, the man who gave it a new lease on life is the same man who will bring it down, Nat McDougall.
This is very hard for me personally to take this thing out. It's going to be an experience for us that's not easy to do.
In 1989, Nat McDougall gave Marmot a concrete and rebar facelift. After decades of the river's scouring action weakened the old dam to the point of collapse.
This dam was built to last, not to be torn out 20 years after it was built.
But now the time has come. After months of planning, the explosives experts from Superior Blasting finally get their hands dirty. Demolition will be done in controlled stages, so excavators can remove the debris efficiently within this tight workspace, one layer at a time. Crew Chief Jerry Dilley has no room for mistakes.
There's a lot of engineering involved to design where the holes are going to be, how many holes, how much explosive weight is going to go in each hole.
Over the next month, they will complete a total of 4 precision blasts, fracturing the dam in 4 horizontal stages. Workers prepare for each explosion by drilling a honeycomb of holes for the charges up to 3 meters deep into steel-reinforced concrete. Then they'll blast the layer, excavate the rubble for recycling, and repeat the process till the dam is gone. But drilling holes for the explosives is tricky.
There's a very heavy rebar mat on 1-foot centers, both directions, horizontal and vertical. So it's a real challenge to get a hole in the right spot.
As the demolition team bores into the top of the dam, biologists on the river confront a crisis. With the Sandy now sealed off from the dam, the fish ladder no longer functions. It too will be removed. But that leaves a summer run of salmon, which has journeyed thousands of kilometers to reach their spawning grounds, trapped in a pool. As quickly as the salmon cowboys can wrangle them, they rush these heat-sensitive fish to insulated tanks and chauffeur them around the dam for release. Jerry's demo team is lining holes with explosives and electronic fuses. They're using a special recipe. 1,100 kilograms of ammonium nitrate and 680 kilograms of high-grade dynamite.
Once you get it all loaded, then you've got people out there hooking them in. You've got people going behind the people hooking them in to check to make sure they were hooked in right.
Jerry handles the final preparations.
Yeah, it's even gonna have a little light show. Put the shot shell primer in the mushroom starter. You put the lead line into the mushroom starter. When you hit the primer, it will ignite the lead-in line, and the lead-in line goes out and ignites the shot.
Company representatives, politicians, environmental leaders, and the media gather at a viewing area to witness this historic moment.
I think today's an important day for this project. We want everything to go smoothly, and that means nobody gets hurt. There's no destruction over above what we planned.
Ladies and gentlemen, we're about 1/2 hour away.
We don't want just a big blob of concrete left after the shot. We want something that's cracked that we can dig.
Jerry oversees one last review.
This shot has been checked at least 4 times by 4 different people to make sure that there was no mistakes made, that it was going to go exactly the way it was designed. In this business, you can't not help but be superstitious.
Are we ready?
Peggy Fowler, Portland General Electric's CEO, is about to find out how well Jerry's done his job.
6, 5, 4, 3.
After months of preparation, Marmot Dam is about to come down.
3, 2, 1.
tons of explosives rip through the top quarter of the dam. It's a perfect execution. The demolition team has broken down the first layer of rebar and concrete. Now, Nat McDougall's crew can get started on the cleanup.
On a project like this, it's a big day when the first shot goes off, because it means not only can we really start doing what we're here for, but we'll also be able to determine how difficult it's going to be to break this stuff and dig it and get it out of here.
The site becomes a chorus line of excavators and dump trucks. They must clear the rubble as quickly as possible for a new round of charges. Portland General Electric wants to recycle valuable rebar and to reuse concrete that would otherwise become landfill. So they carefully separate the steel from the tons of rubble. As fast as trucks can roll with their heavy loads, the debris heads for recycling. Concrete becomes the main course for a diesel-powered crusher that chews 133 tons an hour and spits out jawbreakers and tidy bite-sized chunks. A perfect blend for road fill. Meanwhile, contractors salvage 89 tons of metal and rebar for recycling and take it to Cascade Steel rolling mills. Here, around the clock, workers empty cauldrons of scrap into a 96-ton electric arc furnace. Then, a trio of graphite electrodes drills into the mix. Hydroelectricity delivers 70 million watts of energy to the furnace, enough to power about 50,000 households. It turns the scrap into a molten soup, 1,600 degrees Celsius, that gets poured into billets weighing about 2 tons each, and becomes the raw material for new steel products, from wire to fencing. More rebar will soon be on its way, as crews have now blasted and removed a second 12-foot thick horizontal slice of marmot, reducing its height by half. As the summer wears on, PGE continually monitors the health of the river, ensuring the demolition upstream hasn't impacted the waterway's fragile ecosystem. In just a few weeks, the river will finally be freed from nearly a century of service to the power company. Marmot Dam was built to use the Sandy River for making energy. But first, the water must take a long journey, diverted down miles of canals and tunnels that carry it through a mountain called the Devil's Backbone, and into another river, the Little Sandy, where the water is once again redirected, this time into a 4-kilometer-long wood flume. The flume ends at Roslyn Lake, storing 640,000 square meters of water, enough volume to drive turbines at the Bull Run powerhouse and generate electricity for up to 16,000 homes. As a hydrologist, Gordon Grant admires the skills that brought the system to life.
I'm quite impressed by the engineers of 100 years ago. I mean, these guys didn't have any of the modern tools. They didn't have electronic surveying instruments. They didn't have aerial photos. And yet they managed somehow to engineer these very efficient systems for capturing water, diverting it, and using it to generate hydroelectric power, which was the marvel of the age.
But times have changed. PGE plans to deconstruct the entire hydro system and replace it with alternate forms of energy. For Marmot Dam, it's the end of an era.
Larry, are you clear?
All clear.
It's on the way.
Stage 2 of the deconstruction is nearly over. the explosive team systematically blasts Marmot Dam out of existence. Project manager John Essler is pleased with their progress.
It'll take about 2 more weeks to get rid of this and the rebar. At that point, we pretty much clear the site, wait for the rains to come in the fall. When the rains come in the fall, they wash out the cofferdam. What happens then, as the material migrates downstream, is something we're all waiting to see. It's going to be really spectacular.
Demolition exposes the sleeping giant behind Marmot. 16 billion kilograms of sediment. No salmon can swim over that 15-meter face. With most of the concrete gone, contractors slope the sediment wall for safety. There's nothing but the temporary cofferdam holding back the river. But it's already showing the strain. Scott Zorza now has the most important job on the site, monitoring the cofferdam for problems.
I'm kind of the troubleshooter out here. That's basically my job. One, I got a little leak that we're taking care of at the moment. The worst problem we could have is losing the cofferdam before we're totally excavated down below. I think it's just that sand pocket, but I don't want to take any chances.
His solution? A Band-Aid of concrete, rocks, and gravel. Scott remains confident he can keep the site safe while the weather holds. He must protect the cofferdam until a sediment-busting storm of just the right strength comes knocking.
There's nothing predicted in a long-range forecast. So we could be as late as, October 15th, waiting on a storm. The perfect storm.
For now, the Sandy River remains serene. But Gordon Grant knows how quickly that can change.
On a day like today, we can easily wade across the river, barely get wet. But if we come out here in a couple of weeks, the flows will just be booming through here. So don't be fooled by the bibbly-babbly brook. It's really a very powerful river.
Nearly 4 months have passed since work began at the site. Crews have blasted and sliced through Marmot's concrete and rebar. A last round of charges has taken out the base of the dam. Summer's over. All they need now is the perfect storm to finish the job. The final stage of the Marmot Dam removal project is the most challenging. The team plans to use a storm flood to drive out the sediment behind the cofferdam. Researchers at the University of Minnesota have run multiple tests on the river model, proving in theory that PGE's plan could work. The key is to control the flood by using a breach in the cofferdam. According to their calculations, the crew needs to cut a notch about 3 meters wide into the south side of the clay and gravel structure. Project coordinator Tim Keller knows timing is everything.
The choice of storm is going to be a one-time shot. We're not going to have a second chance. When we choose a storm, right, wrong, or indifferent, we're going to breach the cofferdam.
One of the interesting things about this kind of dam removal is that you really have only one bullet in the gun, and that's the decision point of when you breach.
But it's a decision that could come sooner than expected. The National Weather Service in Portland is tracking an early storm system.
Normally in the Pacific Northwest, we get some nice weather in the fall. This year, man, we just went from summer to winter.
PGE, the power company decommissioning the dam, has asked hydrologist Andy Bryant to help them pick the perfect storm. But it won't be easy.
Sometimes around here, it's difficult to figure out whether or not it's going to rain. It's a challenge just to get a handle on the storm systems that are coming in off the Pacific. You break that down to the Sandy, just a small area, a couple hundred square miles. Is it going to rain in that little river basin? If so, how much? Is it enough to really cause a significant rise on the river? that's a tough question for us to deal with.
The Sandy River is susceptible to the slightest rainfall. As storms move through, it rises and drops quickly. And already, the early rain is causing problems. Water levels are within 1 meter of the top of the cofferdam, about to the limit of what it can hold back. PGE managers Tim Keller and John Essler watch the levels nervously. If the river rises much further, the project will be a washout. The cofferdam will give way, and they'll lose their pumps, equipment, and the chance to control the flood.
Our options are either to wait this flood out and not do anything, or try an effort to get pumps out to notch the cofferdam and breach it like it's designed to do.
For now, they decide to wait for a bigger storm.
Hopefully we can maintain the cofferdam until it's an event that's big enough to really move this material.
But if the next storm is too big, they lose their chance to notch the cofferdam and force as much sediment as possible down the river.
It's been designed to handle a certain amount of flow, and above that it's going to wash out regardless of what we do.
And if the storm is not big enough, the sediment becomes a long-term liability, eroding into the river. Either scenario makes it a hostile place for endangered species of salmon. Years of painstaking work, millions of dollars, and the reputation of the team hang in the balance.
We know the sediment will move out. We know it'll move out at a rate that's been determined by what the flows are going to be and the duration of the flows. With no ability to predict those, we really don't know what's going to happen.
In case their strategy fails, PGE has a backup plan to save the most vulnerable fish. 29 kilometers below the cofferdam, Todd Alsbury, a biologist with the Oregon Department of Fish and Wildlife, joins PGE in a rescue mission.
Well, today we're here collecting 20 pair of fall Chinook salmon as an emergency program. Basically, in case the worst case scenario happens, since we're in essentially a race before the dam gets breached, they're fall Chinook that are listed under the Endangered Species Act.
If sediment stalls in the river, the eggs of these spawning fish could suffocate and die before they hatch.
It's a wild fish.
So the endangered breeding pairs are brought here to the Sandy hatchery. These fish may be the only hope to save the next generation. Workers harvest the eggs and then artificially fertilize them.
We'll raise the juveniles until spring and then release them back into the river so they'll naturally out-migrate to the ocean.
And the rescue is just in time. Early the next day, the project reaches a crisis. Overnight, a storm system has filled the reservoir behind the cofferdam to capacity.
This morning on my way out, I got a call just before I turned into the access road, and I was told the river was at 1900 CFS, so I drove a little faster on the access road getting in here.
1,900 cubic feet per second. That's 23 cubic meters per second. A number that gets everyone's attention.
It was not what it was supposed to be. 1900 CFS is the design for the cofferdam on what it's designed to hold back. Any higher than that, it's anybody's guess.
The dam could fail at any time. And there's another problem.
The bridge washed out on that back corner there, and it sunk probably a foot.
The bridge over the diversion canal is collapsing. Without it, machinery can't get from the bank onto the cofferdam to remove the pumps or cut the important notch.
Are you comfortable still having equipment come across here?
No. Right now, Mike's looking at it to see if he can get across it.
The entire project is in jeopardy.
We've now isolated the cofferdam with no way to get equipment back out there to deal with the pipes, the pumps, the casings. You know, that's unacceptable.
But suddenly, the weather clears, giving the team a chance to assess the situation.
Oh, a little wind. That should help.
Okay, so call now to the forecast, see if they're thinking that this...
John Essler mobilizes the crew to get ready for the breach.
Does Mike have his excavator guys on their way down?
They're on their way.
Okay.
But his next step depends on the weather.
National Weather Service, Portland.
This is Andy.
Hi, Andy. Tim Keller here. I got John Essler, too.
Hi, Andy.
Hello.
Well, do we have a forecast yet?
We do.
Let me just check something here and see.
The Weather Forecast Center is tracking a new system.
The models are more and more pointing towards development along this part of the frontal band. That's going to be the player for tonight.
So Tim, looking at the hydrograph, this looks like the one that's going to do it.
Crest is 2500 at 5 p.m.
Oh, boy.
The weather has forced their hand. A major storm is headed their way, and the expected water levels will certainly wash out the cofferdam.
We're not going to hold off the breach.
They have no choice.
It's going to go to 2,500.
We got to keep going.
We got to get going.
It's time to put their plan into action.
Let's do it.
Okay.
All hands report to the site. The crew must turn off the pumps and remove them from the cofferdam before the storm hits. But the bridge can't support the team's heavy machinery.
Will that forklift go high enough for them?
Should.
Time to improvise. Art Burnett, one of the most experienced workers, will use a light forklift in place of the heavy excavator.
Looking at the bridge, with the water coming up as fast as it is, it's hard to tell, you know, if the forklift's gonna do what we need it to do.
It's up to Art to get the pumps out and then start to notch the dam. Two brave spotters on foot will try to keep Art and his forklift from tumbling into the river.
Hopefully, it'll all go good and nobody will get hurt out here.
As the pumps are turned off, water will quickly start to penetrate the cofferdam. They're on borrowed time.
Once we get out there and pull the first pump on there, we in a sense have lit the fuse. And the integrity of that section of the cofferdam is weakening as we speak. At that point, you can't count on that cofferdam.
Because it could just wash out underneath us. As soon as the pumps are gone, that's possible. That can happen to us.
7 pumps left to pull, and the river's rising. Every minute matters as water soaks into the structure and weakens it further. The project enters a new phase. Gordon Grant arrives to see if the model from the lab lives up to expectations in the field.
Removing this dam up till now has been all about big machines and big dirt. People coming in, digging the old dam out, exploding it up, transforming the space through machinery. But starting this afternoon, we move to a whole new rhythm and a whole new cycle, where it's the river that will do the work. The river will cut down, the river will move the sediment, and what we're left with will be up to the river and not up to the machine.
There's a growing tension at the site. The weather remains dynamic, with the promise of a knockout punch. The pumps are finally out. What's left is the most perilous job. Art must move out to the far side of the cofferdam and make a notch into the unstable structure.
If it's raining hard and the water's rising fast, we just need to keep the guys safe.
Gently, Art and his guides begin scraping into the top of the cofferdam. They must cut a notch using the model as their guide and push away just enough sand and gravel to give the river a head start. It's a risky operation. One wrong move and the ground could give way, and Art and his spotters could be swept into the rising waters.
The final stage of the project is underway. As soon as the forklift starts cutting into the cofferdam, a stream of water begins seeping through.
There's all this planning that goes up to that final breach. But after that point, human control just evaporates. We just have to let nature work. We have to let the river do its thing.
Behind the dam, the reservoir reaches capacity. The diversion canal now acts as a safety valve, releasing just enough water to keep the energy of the flood in check. But once the crew blocks the canal, all hell will break loose.
As soon as they fill that diversion canal, this is just going to explode on us. You can hear it.
Yeah, make sure my tires don't get too close to the edge. I don't want to be sliding into this thing.
Art Burnett knows the ground beneath his forklift could go at any minute.
It would have been neat to watch it from a distance, I think. On top of it, it's nerve-wracking. What if the thing does wash out under? What happens then?
There are some big doings happening underneath that thing. Look at that. That is very cool.
With the notch nearly complete, it's time to block the canal and move the mission into hyperdrive.
Hey, Dave, you got a copy?
Yeah, go ahead.
We need the rocks in the canal now. 10-4.
Workers close the diversion canal,
Okay, here we go.
boosting flows behind the cofferdam by an extra 847,000 liters a minute. The river reacts quickly.
The velocity of the flow is starting to increase through here. It's going through what's called critical flow, the river equivalent of a sonic boom. Wow. Wow.
The water's energy cuts through the sand and gravel like a giant scalpel.
This is the geological knife right here. I mean, this is a geological knife.
Years of planning comes down to this moment. Art's job is done. It's time for the river to finish the project.
Watch yourself here, gentlemen. Whoa! Holy. It's starting to go.
All at once, the sediment starts to give way.
We gotta back up, we're starting to lose the bank. Hurry up.
The crew must pull back now.
Water's coming at us quick, or we're losing the bank.
As we're backing up, all of a sudden the dam just lets go. And a spot probably 10, 15 feet across just washes out. That's definitely the most nerve-wracking time of it.
Walls of sand and gravel 3 stories high peel off like a glacier losing its ice.
My God! This thing is just having. I can feel the ground moving too. I have never seen anything like this.
The sediment is now a locomotive of boulders, gravel, and sand.
You know, already look how much. Look at this canyon we've done here. Holy smoke! In the 5 minutes, you know, you look one way and something else is happening somewhere else. Oh.
Just 2 hours after notching, the Sandy cuts down to its original riverbed at the site of what was the Marmot Dam.
It was just a roar, like you'd expect any waterfall to sound like. I thought it was spectacular.
By nightfall, the Sandy runs free. Tim and his crew are exhausted.
It really cleared out fast once the notch was cut. It's just amazing the power of the river.
And relieved, the biggest threat to the project has moved downstream.
People have worked many, many months and years on trying to figure out exactly how this would happen. And to finally see it come to pass, I think it just gives everybody a great sense of satisfaction.
The next morning,
Gordon returns at first light.
It's gone! The whole thing. The river took it all. One night. Unbelievable. It's like the river doesn't even remember that there was a dam here.
Just 18 hours have passed since the Sandy began carving through the cofferdam. And the outcome is astonishing. The river has cleared a channel for itself. The biggest deposits, about 98,000 tons of sediment, some of it nearly 100 years old, have broken free.
Yeah, there's a hint of sulfur in the air, and I think it's coming from all the organics that have been buried under this reservoir for, I don't know, 80, 90 years.
The project is a huge success. Where there was once a dam, now there were only a few old well casings. The whole area will become a public nature reserve. Portland General Electric is donating 6 square kilometers for a trail network. 2 days after breach, rare salmon are already swimming through, just as John Essler had hoped.
I saw a paracoho. To me, it's a small indication of how quickly this system is recovering. The river's returned to being a river like it was back in the 19th century, from there back in time.
The Sandy begins a new history. The team has, in effect, recycled the river.
We borrowed the river's energy for 100 years. We used it to light our houses, to run our computers. But yesterday, the river took it back.
The Sandy River has returned to the wild.